my name is Eva Uliberry, and I'm one of the project managers for the Oil Spill Radar project under Oscar Garcia. We're going to go through all of the subcomponents we've built this year and explain how everything works to you. For further details on how the circuitry is built, you can refer to 2011's video they created. It's on YouTube under Radar FSU.
The first component that will be explained will be the linear actuator. The actuator runs on 12 volts, and to power the actuator, the user will plug in the red and black wires onto the rails accordingly. After the actuator is receiving power, the user will plug the USB into the Raspberry Pi. This will help prevent errors with the Polio board. There is a red light that means that there are errors on the controller and they need to be cleared. If there is a yellow flashing, it means that the JRK is waiting for an input. If there are errors, you will need a Windows computer with the JRK configuration utility, which can be downloaded from their website, and it can tell you what the errors are and how to clear them. The web page is also really helpful for troubleshooting. After all the errors have been cleared, the user will open a terminal on the GUI and type the following code: sudo chmod 777/dev/*. This can be seen in the user manual for clarification. Then the user will open a web browser and go to the local host in the GUI. This is where the GUI will control the actuator and give it the correct range of motion. Once the user is in the GUI, they will click on the actuator button in the left column. This will have the user enter in an angle where the motor will adjust and give it the desired angle.
We have attempted to get the data capture to work, but have not had any luck. We were unable to determine if the error was hardware-based or software. However, due to the amount of hardware issues we have encountered this term, it would be in the future group's best interest to move the hardware to a more permanent and stable solution. A lot of work was put into rebuilding the database so that we could capture data. Here, we created two databases, Senior Design and GPIO. GPIO was intended to be used to set and control the input-output of pins on the Raspberry Pi. Senior Design consists of three tables: samples, sets, and system. The systems table at the moment possesses no significant impact on the capture, while sets and samples are absolutely necessary for data capture to occur. The samples table contains all the data collected from the antennas. They are stored here, each with their own primary ID, but uses the set ID as a foreign key for the sets table. The sets table contains data entered from the GUI that initializes the data capture. The primary key, ID, is used to reference the data set from samples using set ID.
To set up the wave generator, the Arduino library must be downloaded from the product website. Before use, you need to make sure all pin connections are correct. The pin ND2 is not an actual pin. This is a digital pin which will be controlled using the program. A pulse width modulation code needs to be set to change the speed of the motor. To determine this code, a graph is given. The motor shield is powered by a 12-volt power supply. The red and black wires need to be connected respectively.
To ensure the connection, a blue light should on when the power is supplied.
A green light should turn on when the motor is moving in the forward direction. A red light should turn on when the motor is moving in the backward direction. Brackets are available on the back of the wave generator to ensure the position above the tank. You can also use a clamp